Okay, so for this part of the lab, we're going to do simple tension, and this is something that we've seen in video in class a number of times. Here we're going to do it almost live with our own video. And what this does is exert a force on either end of this piece, and this is called the dog bone because it's narrower in the middle and wider on the ends. That means that it'll break in this middle section. And what we'll see when we go to break this is it's probably going to break near one end or the other because they tend to be slightly thinner on one end or the other. So for this portion of it, we need to take our initial diameter, and then we're going to take and we're going to put it in this machine. And all of these diameters we're taking, you need to calculate the initial volume. So we're taking the diameter here. We could also take the length. We don't really need to do that. Perhaps we will. The length essentially becomes a constant because what we end up using is the change in length. And I know that gets confusing for some people. I usually just say use 4 inches because, again, the number, because it's a change in length, it really doesn't matter. But we'll take the initial diameter and perhaps the initial length here of the skinnier part towards the middle.
So it's 0.244.
Okay, 0.244 is our initial diameter, and Jesse's going to record that. And again, the actual length between there doesn't really matter because it's going to be a constant. Let's just say that it's 4 inches. You can use that for your calculations. Again, it's not going to matter. So in the operation of this machine, it goes between these jaws, and then it ends up getting secured in here. And we're going to pull on this in incremental lengths. So we're going to stop the machine every 25 thousandths of an inch and record the force data. This is going to allow you to make a graph. Oops. That will look like the stress-strain curves that we talked about in lecture. And I'll talk about that as we start taking these measurements. So this is now secured in here, and we're going to zero out our load and our length. So now everything's 0 here. You'll see that the load starts to increase a little bit. The machine is so sensitive that even changes in relaxing of the jaws and things like that go on here. We're not going to worry about that because we're actually going to go up over 3,600 pounds. So the 3 pounds that we're reading right now doesn't really matter. So we're going to stop this every 25 thousandths of an inch, and we're going to record our load information. And it doesn't really matter if we're not exactly on 25 thousandths of an inch because these are just data points that are going on a graph. You're going to use these to calculate your stress and strain, and you're going to make a graph of that information. So the other trick with this is that the load immediately drops when we press the stop button. So I'm going to be watching the load carefully because Jesse's going to be running the machine and trying to capture the load at the time that the stop button's pressed, not the point at which it relaxes to. All right, so we're going to give it our first pull here. So Jesse's going to hit the up button, and you're going to see the extension increasing. And you can see that the load is increasing pretty fast right now, 613. So we're going to record our load as 613, and our extension is 0.026. So this is our first data point. And as we make our stress-strain curve, if we think about what we saw in class, it goes up very, very quickly, in that it increases at a decreasing rate, and it will level off, and then it'll drop slightly, and then the part will break. And we will see that here. So for the first 3 or 4 pulls, it's going to increase very, very fast. All right, so let's give it another run here. I'll stop this one at 50. 1002. So we've already got 1,000 pounds of load in our first 2 pulls. All right, let's keep going. This is actually going to take several, it takes almost 20, 25 of these starts and stops. 1539. $21.05. 2518,
21.
2118.
No, 25, 21.
21. This is why when we do this lab and you're in your teams, we have many people watching the load, because picking the point at which it stops is tricky. 27.
26.75.
$28.16.
Yeah, it looked like it.
$28.92. $29.62.
62. $30.22.
30.22. All right, let's stop here for a minute so we can see we've got a 1/4 of an inch extension now, 252. We're almost to our 3,000 pound load. So we've gone through that very steep curve. That steep part of the curve is our elastic deformation. As we see the load increasing at a decreasing rate, we get into that plastic deformation. So if we think about what that means, when we were in that elastic part, that was sort of like the first 3 pulls, if we had taken this piece of material out of the jaws, it would have returned to its original length. Now we're in the plastic deformation portion, so we're actually changing the length of the bar permanently. So if we took it out, it would be longer. And we'll see that as we go on here. So right now we're a 1/4 inch longer, and we're going to go somewhere between 1/2 and 3/4 of an inch before this breaks. This is an aluminum alloy that we're using here, so it actually extends quite a bit before it breaks. All right, so we'll keep going here now. You'll notice not much has changed over here. Still looks like a piece of metal in 2 jaws. 3089.
Jesse, move your fingers.
3104. Yeah, so you can see we went from 89 to 104. That, we're not increasing our load a lot at this point. And we're going to see that for quite a while. All right, you can keep going. $31.49. Hmm?
82.
Pardon?
31.82.
$31.95.
$32.38.
Now you can see when at the point at which it stops is not necessarily the maximum of load that we've had in that period of time. You see some fluctuation in the load, and that's to be expected. All right, so now we're at 0.4. We're not quite to a 1/2 inch extension, so we'll keep going here. We're going to want to be watching for when the load is no longer increasing.
32.50.
$32.68. $32.63. All right, so that one dropped a couple of pounds. I still don't think we're necessarily to the point where we're going to see the drop and decrease. I think we're right at the top of our curve. It's going to fluctuate a little bit, so we'll see what the next pull is here. And this is going to take us to a 1/2 inch. 3220. So that was actually down again.
Mm-hmm.
All right, so just so that we're all prepared here, this makes a really loud pop at the time that it does break. Sometimes we're lucky and we can feel it narrowing. As I'm feeling this, now you recall that I said at the beginning, it's likely that's going to break at one end or the other. Right down in this area here, you can feel it being narrower, so I think we're getting close to it breaking. We've seen the load drop a couple of times. I don't know that it's going to be visually possible to see that, but I think it's going to break down at the bottom. Yeah, it's definitely got some narrowing here. That's that necking that we talk about in the video that we saw in lecture. All right, so again, be prepared for a loud pop. And there's the loud pop. That even though we've done this many, many times, we still find shocking. So we can see down here that it did break where I thought it was going to break. Our extension at the time that it broke was 0.552. So it broke at a bit over a ½ inch extension. And if we look at the load at the break was 3064. So you'll see that it actually broke at a lower load. So that is that point where we've come over the top of the curve and we've now reached the fracture of our material. So when you're designing, that's of course the point you never want to get to. All right, so that is our tensile testing portion of the lab. Again, we'll go over in recitation how to use this data that we have here.